Hey, sixth graders, Mrs. Zimmerman here. Today I've got a lesson for us on the distributive property. So we're going to keep using algebra and we are going to be distributing. So my screen is here. Let me pull this up and I'm going to head to the front. Here we go. Okay, so what we have today is the distributive property. And if you think about the word distributive, it really kind of has the base word distribute, right? Distribute, to hand out, to pass out, to give out. And that's kind of what we're doing in math today. So before we do this example here in the box, let me just work over here for a second. What if I had 3 parentheses x parentheses? What would we do with those two numbers? We multiply them, right? Because two numbers right next to each other tell us to multiply. So what if I had 8 times 6? Two numbers right next to each other, one of them is in parentheses. Well, what is 8 times 6? 48. That's how we do that. Two numbers next to each other mean to multiply. So if we go back and look at the example I have here, distributive property really just means to distribute. The 4 parentheses, n plus 5 parentheses, and all we're really doing is distributing the 4 to both numbers. So let's think about it. This 4 right next to the n says to multiply. So what's 4 times n? Well, we don't know what n is, so it really would just be 4n plus, what's 4 times 5? 20. So now I have 4n plus 20. I just distributed that 4 to the numbers that are in my parentheses because being right next to each other, that means we have to multiply. And now I go down to my 4n plus 20. Can I make that any smaller? If you remember from the last lesson, we made things smaller. And no, I cannot. So then I'm done. And that's how we do distributive property. So let's look at a bunch of, oh, we just did that one. Okay, let's look at a bunch of examples. Here's another one. Okay, I have 12 times 2y minus 3. So the 12 is what I'm multiplying because that's right next to the parentheses. So here we go. I have to multiply it to each part in the parentheses. So 12 times 2y is going to be 24y. I just multiply the numbers and keep the variable. And this time it's a subtraction sign, so I do minus. And then what's 12 times 3? 36. And there's nothing else I can combine to make it smaller, so that would be my final answer. Here's another one. 7 times a plus 2. So the 7 is what I'm distributing to each number in the parentheses. So 7 times a, remember there's a 1 there, even if we can't see it. So really it's just 7a plus 7 times 2 is 14. And that's it. It might seem like I'm going through these kind of fast, but it's pretty simple once you get the hang of it. So let's do another one. 1/2 times 6y minus 2z. Okay, well, the 1/2 is what I'm going to distribute to each part of the parentheses. So 1/2 times 6y, well, what's half of 6? 3. So I have 3y minus, what's half of 2? 1. And this has a variable, so I have to put that there. Now I have 3y minus z. Is there anything I can do to make this smaller? No, I cannot combine these because they do not have the same variable. So they have to stay separate. That is my final answer. Okay, next one. Oh, we've got a bigger one here. Let's look at it. 9 times 6 plus x plus 2. So I'm going to distribute the 9 to each part, which means I have to do it 3 times now because I have 3 parts. So 9 times 6 is 54 plus 9 times x, which would just be 9x, plus 9 times 2, the last part, you can't forget it, is 18. Now, can I make this any smaller? Yes, I can. right? I've got two numbers here with no variable, so they can be combined. What's 54 plus 18? 72. Plus 9x. Now that one is finished. Let's do another. Here we go. Okay, we've got another one that's a little bit bigger. We're going to multiply by 7 times 2 plus 6 minus 4d. Okay, so we got a lot going on here. Let's start with the first one. What's 7 times 2? 14. Plus, what's 7 times 6? 42. Now we have a subtraction sign. What's 7 times 4? 28. And my variable is d. So now I have 28d because I multiply the two whole numbers and then tack on the variable. Can I combine this to make this smaller? Yes, right? I've got two numbers here with no variable, those two. So, oh, I don't need to write it again. 14 plus 42 is 56 minus 28d, and I cannot make that any smaller. So there we are. Okay, let's go ahead and go to the next thing we're going to learn, which is combining like terms. So before we can combine like terms, we need to look and see what is a like term. Well, you're already familiar with this idea, you just didn't know it. A like term are any two numbers that essentially can go together. Remember how I said you can only combine numbers that match? Like the 2 and the 19, both have no variable. So we would call both of those like terms. The 5x and 2x, though, are not included in that because they have variables. So we don't call them like terms, at least not to these ones, right? Because now, what else do I have? I have an x and I have another x. So these two are called like terms. So we have two sets of like terms here that we can combine together. What's 5x plus 2x? 7x. Plus, what's 19 plus 2? 21. So now I have 7x plus 21. Is there anything else I can do here to make this any smaller? No. So that's how we combine like terms. You don't have to do anything other than just get them as small as you can. Here's another example. We have 3x plus 9 plus 2x minus 5. Okay, think about this. What goes together? We have a 3x and a 2x. So we know for sure those will go together. And then I have a 9 and a minus 5. So let's combine. What are my x's? 3x plus 2x is 5x plus, so then I have a plus 9. What's 9 minus 5? 4. So then it's 5x plus 4. It's very important that you pay attention to the signs of these numbers, right? Because this is a minus 4, which means we would have had to subtract the 5 there. You can't forget that. But let's do some more, okay? 8 plus 3z minus z. Well, what are my numbers with no variables? This time I just have the 8. It has no like term. So we just have an 8. And the other like terms I have are z's. So here we go. We're ready to do our combining. 8 plus 3z minus z. Well, what's 3z minus a z? Remember there's a 1 there? So 3 minus 1 is 2. So I'm left with 2z. And that's it. I can't make it any smaller. Next one. Here we go. W's in regular numbers, 7w plus 11 plus 3w minus 4. Okay, I've got w's that can go together, and I've got 11 and a minus 4 that can go together. So first we'll do the variables. What's 7 plus 3? 10. W. Then I have a plus 11 right here, minus 4. What's 11 minus 4? 7. So 10w plus 7. Another one. Oh, we got b plus b plus b plus b. Okay, so let's think about it. They're all like terms, right? They all have a b. There's none with any other variable or anything else going on. And there's a 1 in front of each of these. So how many b's are there? 4 b's. That's it, right? 4 times b would be the same thing as b plus b plus b plus b. Another one, just like that, is 3 y's. So count them up. 1, 2, 3. So we would just write 3y. Oh gosh, look at this one. Okay, now before I can combine like terms, I see something happening right here. I've got a 2 next to numbers in parentheses. So what do I have to do there? Distribute. I can't combine like terms until everything is distributed. So we have to do 2 times z and 2 times 5y. So let's copy. We have 7z plus, what's 2 times z? Just 2z, minus, what's 2 times 5y? 10y. Combine like terms. What do I have that's like here? The z's, and then my 10 is a y, so that doesn't go together. I can't do that. So I'm going to have 9z plus 10y. And that's it. Looks like we got a couple more. Okay, this is the same type of problem. We have a distributive property we need to take care of here at the front. So let's distribute the 3. 3 times b is 3b plus 3 times 5 is 15, and then we'll copy the rest, plus b plus 2. Okay, what do we have that's common here? Well, the 15 and the 2 have no variables, so they'll go together, and the 3 and the b both have a b. So my final answer would be 4b plus 17. And I can't make it any smaller, so that's it. All right, this will be our last one. Here we go. All right. Again, we've got a distributive property. So let's copy down the first part. 2c plus 3 times f is 3f plus 3 times 5c is 15c. Like terms here, what do we see? Well, I choose 2 c's, right? I've got this 2c and a 15c. What's 2 plus 15? 17c plus 3f, because there's no other f's to combine. So that is it. And I believe that is all we are doing. Okay. All right. Hopefully I didn't go through that too fast. You can always pause it just like always, but once you get the hang of it, the distributive property can be pretty easy, and it's also really handy when it comes to solving equations and expressions, so you'll use it a lot in the future. See you next time.